Dr. Stewart, my name is Daniel Dhoyos. I started a company in South America that helps people purchase products from international sellers online. I'm currently working in my master's in IT and management here at FAU. If we go to the next slide, we'll see a chart provided by the World Bank, where we can see the total global import of goods and services that was 22 trillion in 2016. It was continuing an upward trend since the 1970s. In order to access imported products, some people go online or go to a local retailer. Although both options are effective at getting products into customers' hands, they each have their downsides. Today, we'll talk about a third option, which comes with unique benefits. We'll address the context, the technology, the competitive environment, economics, and the organizational implementation of this innovation. Buying products from other countries comes with problems, especially because a very large amount of online retailers do not automatically ship to most countries. People who live in a country where a product sold online does not ship regularly pay extra to purchase a product from local retailers that imported that product. One of the biggest problems with brick and mortar retailers is that they must charge much more than what it costs them to acquire the product because the extra overhead costs by their physical footprint. Some people have learned to arrange their own shipping. They send their product to a shipping company within the allowed range of places where the product is automatically allowed to ship, and then ship that product from the shipping company to their locality. This is not a long and complicated process for the buyer to coordinate. Since the final shipping route is not known by the seller, the total taxes and price of the shipping are not automatically calculated. Some companies facilitate this process by having a person that finds the best shipping route, calculates the total taxes, insurance, and shipping costs, and charges a commission for the service to each customer. But this is a very labor-intensive process that does not scale. Our proposed application would automate this process, lowering the labor costs and making everything faster and more efficient. The technology, we'll go over the technology right now. The software, hardware, functionality, and impacts. The software, it's a browser extension. So these are also known as add-ons. They are programs designed for and entirely integrated into the browser. Some are written using web technologies such as HTML, JavaScript, and CSS. They have a small user interface and are extremely useful because they add extra capabilities to the user's browsing experience. The hardware required to run this application will be the user's internet-connected device and servers provided by the Backend as a Service company. Backend as a Service is a cloud computing service model that serves as the middleware that provides developers with ways to connect their web and mobile applications to cloud services via application programming interfaces and software development kits. Some of the included features are cloud storage, push notifications, server code, user and file management, social networking integration, location services, and user management. So what's the actual functionality of this application? The browser extension calculates the cheapest and quickest way of getting an online product across country borders into the customer's hands. It orders in websites and sends shipping directions to shipping companies. The impacts of this technology will be that customers can more easily and cheaply purchase products that were made abroad, which are available online. Sellers will get orders from customers who were previously not able to purchase from them, or who just thought the purchasing price was too high, so they're now able to get it for cheaper, and the sellers are able to get new customers. The shippers get more people to use their product because with the extension, users can effortlessly use the shipping company's services automatically. Now for the competitive environment, let's define the players, assess their responses, and show how their responses to the innovation, and show how we can keep a competitive advantage. The customers for this product would be, as described before, people who want products that are sold online which are either too hard to get or too expensive to get. The main direct competitors would be other services that help people import products sold online. These are companies like Busca Libre and Comprasmart. The main indirect competitors would be online retailers and brick and mortar stores that import products. Trading partners are online retailers and shippers. They can also be competitors at certain points when they ship to the same places that we want to uh, ship, or when they're offering services very similar to ours. So possible responses by them could be to create an application similar to ours or to lower their prices. In order to keep a competitive advantage, we must continually be improving the application, making it simpler, making it more efficient, and building relationships with trading partners so that our ecosystem can feed on each other. The economics. Now we'll go over the cost, revenue, and possible scenarios. Programming for this application should be more complex because this application needs to get information from web pages, categorize products from tariff purposes, calculate the fastest and cheapest shipping routes using different shipping companies. So a programming team like the one in Twitterrific should spend no less than 1,100 hours, maybe as much as 4 times as much. This means between $165,000 and $660,000 in programming salaries. For the backend, instead of data centers and servers, we will do backend as a service. This service reduces a development team's need to construct complex backend infrastructure. The Salesforce app cloud costs between $25 and $500 per month, and competitors like Backendless cost around $99 per month. The app design, according to the book The Art of the App Store, for a AAA 3D app should be upwards of $50,000. For Doodle Jump, it should be between $3,000 and $5,000 depending on the scope. The proposed browser extension would be much closer to Doodle Jump than to a AAA 3D app, so the total cost of the package should be between $3,000 and $5,000. The translation, for a small word count applications, it's between $300 and $1,000, and for a large application with thousands of apps, it's between $5,000 and $10,000. Since the described application will have a description and user notes that also need to be translated, we should expect the translation to be closer to the higher end of this range. For quality assurance, to ship efficiently and provide accurateness in prices, errors must be corrected. Simple applications usually cost between $3,000 and $2,000 for their quality assurance, while large role-playing games can cost upwards of hundreds of thousands of dollars. So this application should be kind of in between them two. We have lots of countries that we're shipping to, so we do need quality assurance in each one of them since they each have different rules. Marketing should not be a large percentage of the cost. According to the Art of the App Store, though traditional game companies can spend millions, marketing budgets can be successful for next to $0 to $2,000. If you go the social media route externally and then use extra money to build social features directly into your app so that they keep paying dividends, at first you would spend a large amount in marketing investment to get customers to actually know your application, and at the end that amount would drop off since users will grow the extension using social features to share within their own social groups. Our revenue, the total international merchandise traded by G20 countries in the first quarter of 2017 was $3,245 billion. If we're able to get 1% of that traffic to go through our application, we should get $32.46 billion being purchased through the application. And by charging 0.15% of the cost of these products, we would get $49 million per quarter, which roughly translates to $588 million a year. In the best case scenario, the programming would be the same as Twitterrific, $165,000. The backend would be around $500. The art design would be $3,000. The quality testing would be around $2,000 since it will be done mostly in-house. Marketing and PR, only $30,000 to get us going, and once the application has enough users, they'll do the PR for us. After 2 years with a 15% maintenance fee per year, our total cost would be $234,788. In the second year, we should have, for the revenues in the second year, we should average 1% of the G20's trade going through our application, which would give us $588 million of revenue in that year. So if we subtract the cost by the revenue, we should get $587,765 million. In the worst case scenario, the programming would be $660,000. The backend would be $200,000 since we couldn't do it in a backend as a server. The art design would be $10,000. Translation, another $10,000. Quality testing, $50,000. Marketing and PR, $500,000 since we couldn't get the application to really get enough customers. There would be a 20% year maintenance fee, and after 2 years, your total cost would be $1,716,000. By the second year, we would have 0% of the G20's trade, so the revenue would be negligible, and our total income would be negative $1,716,000. The most likely scenario, though, would be that the programming is around $200,000, a little bit more than Twitterific. The backend would be $1,188 on the high end of the backend as a service providers. The art design would be around $4,000. There's not a really big UI, so we don't really need that much art design. For translation, we plan ahead, so we don't need to spend too much money translating, using text instead of images to easily translate to every single language, so around $5,000. Quality testing will be done mostly in-house, so around $3,000. Marketing, maybe $50,000. And in 5 years, we should get around 1% of the G20's international trade of products. So 5 years at 18% maintenance cost would equal a total cost of $451,000 total cost. For a revenue, after 5 years, we would get 1% of the G20's trade, which would be $588 million. And if we subtract the cost by the revenue, we get $587,548,000. Now the organizational implementation. What are the critical factors, major risk, mitigation strategies, and likelihood of implementation? This extension needs to find shipping routes, calculate total costs, and place orders in order to provide a simplified customer experience and attract new customers through social features. We also need to create company procedures that ensure that we are legal in every country we go to, since every country has different laws. If we're not legal in a country, we don't have access to that market. We also need opportune mitigation strategies to possible reactions by competitors. And all of these will affect the most important part, which is the user adoption. If we get enough users to actually use the application, if we get all of these critical success factors done right, then we should have no problem having good customer adoption. I think the likelihood is high of implementation of this innovation. Although achieving all the critical success factors will not be easy, there are no major issues that appear to be unresolvable. So with dedication and perseverance, I think this innovation could be successful. Today, we analyze the context in which the servers will exist, the competitive environment, and what the proposed service needs to do to survive, the economic feasibility of the project by comparing the possible costs to the possible revenues, and the organizational implementation along with the factors that could either make or break the innovation. We conclude that this innovation has a high chance of being successful. During the rest of 2017 summer semester, the proposal will be subjected to criticism by classmates and the professor, and the corrections and improvements will be applied. Going back to the World Bank statistic from the beginning of the presentation that states that in 2016, continuing an upward trend, there were 22 trillion worth of products that were imported globally. If we create an application and continually improve it, if we create this application and continually improve it, we should have no problem with getting a good piece of this pie. Thank you. Any questions?